We are from Group App, and the project title is Dynamic Compaction Method in Different Countries. I'm the leader Lee Chun, and my teammate is Jing Kang, choong and Quan. For the abstract, the research looked at the dynamic compaction densification method that is applied in different countries. Dynamic compaction is a soil improvement technique that densifies soil and field by using drop weight. Objective of this subject is to study the soil condition and the effectiveness of dynamic compaction densification and to find out the implication of dynamic compaction for construction work. And the location of the study for Article 1 is Ausaloya, Iran, and Karafosa Hypermarket and Trade Center in Bursa, Turkey. And the third article is located in Changi, East Singapore. To get a better understanding on the soil condition and the effectiveness of dynamic compaction that is being carried out in other countries, several research papers related to dynamic compaction has been discussed, compared, and analyzed. Dynamic compaction is one of the best economical method for soil improvement. For the introduction, dynamic compaction is one of the soil improvement method that used to achieve deep ground densification by creating high energy shock wave resulting from the drop of high powder. The technique was invented and developed by Mr. Louis Mernert in the 1960s. It is commonly applied for building foundation or root and rail embankment foundation on loose material. The technique requires the dynamic effect of high energy impact caused by raising powders weighing between 10 to 40 tons from a height of 10 to 30 meters and dropping the weight repeatedly on the ground at the regular space interval. Article 1 describes the characteristic of geological site, geotechnical aspect of material and dynamic compaction in Ausaloya, Iran. And Article 2 highlights the design, construction, and performance soil improvement by heavy dynamic compaction. Article 3 describes the dynamic compaction densification method used in Changi East reclamation site in Singapore for improvement of reclaimed site field.
I am Kang Quan. The objective of this study is to study the soil condition and the effectiveness of dynamic compaction densification, and to find out the implication of dynamic compaction for construction work. Part 3, Theory and Definition. DC is an engineering process used to increase structural bearing capacity of soil by control high energy tamping. The reaction of soil during DC varied with soil type and energy input. DC method is invented a long time ago but modified by Louis Mernert and his commercial company. Part 4, Geology of site. In Article 1 is Ausaloya, Iran. Ausaloya is the capital city of Ausaloya country in Bushehr province, Ireland. The coast is located near to Four and Four Mountain in north. As a result, the earthquake is reserved in Ausaloya. Based on some official results, earthquake magnitude of Ausaloya is 7.2 and peak ground acceleration is 0.3 gram. Bursa. Site of project is located at about 5 km west of Bursa on the main highway from Bursa to Ismail. This site is covered with alluvial fan deposit for river Nilufer flowing north. The site was originally a dam area for excavation, so the site contains depression as deep as 14 meters from present ground elevation. Third, Changi, Singapore. Project site was placed in the eastern part of Singapore, which was discovered as future expansion for Changi Airport. The project needs soil improvement work for treating the underlying compressible clay and also the granular field, as the sand was filled with average thickness of 10 to 12 meters.
I'm Choong, I will be presenting the types of problem. In Ausaloya, some basin needs to be excavated to prevent the erosion of filled material in sea due to the site being near coastal area. The coast is located near the earthquake hazard area with earthquake magnitude 7.2, which will cause serious damage. Therefore, dynamic compaction was used to improve the soil. In the Bursa, Turkey, the site contains depressions as deep as 14 meters from present ground elevation. This will increase the difficulty of land reclamation. Some parts of the site were covered with uncontrolled fill formed by dam construction material. The site is also located in first-degree earthquake zone with highest seismicity. In Changi, Singapore, it related the existence of loose granular soil which is prone to liquefaction due to impact of surface dynamic force. The characteristic of low shearing resistance and high compressivity on loose granular soil at construction site may be subjected to bearing capacity failure and large settlement. Next, for the equipment and process, in the Article 1, material to be filled in are alluvium deposits which include sand gravel with some cobbles and boulders. For the process, first, some basins with dimension 300 meter times 300 meter were made to prevent erosion from seawater. Second, a crater is formed at the impact point that up to 2 meter deep. Several phases of damping implemented across the site, depending upon the level of improvement required, followed by the ironing phase, which consists of dropping the weight 10 and 18 tons from a height of 5 meter to 15 meter as side by side. Next, various combinations of weight and drop height were used. Area of treatment were divided into 4 zones according to filling material depth. In each zone, some trial areas selected to perform dynamic compaction in order to get optimum patterns. Last, by the end of the dynamic compaction, 3 in situ and loading tests was used to study the effect of dynamic compaction. For the Article 2, dynamic compaction is usable in unsaturated soil or granular soil under table groundwater table. For the process, first, high energy impact is transmitted into the surface of the ground which is initially compressible and with low bearing capacity. Ponder weighting from 18 tons to 25 tons were dropped from height from 15 meter to 25 meter. Second, the crater formed by the ponder were backfilled with soil of platform, will result in a settlement of site and densification. Third, the performance of 2 different trial areas based on the improvement characteristic according to pressure meter tests enable the determination of grid for damping and number of blows per unit. The last phase of damping is ironing. Systematic pressure meter was used to test the performance of the dynamic compaction.
My name is Kang, and I'm going to present the Article 3 equipment and process. The process to investigate the dynamic compaction is, first one is the shape of powder. The powder consists various shapes such as square, circular, and hexagon. The thickness of powder is also varied. The second is the lifting and dropping mechanism. A powder is lifted by a crane with a winch system for the powder that are too heavy. A tripod is used to replace cranes. Third is the pore pressure response in the soil. Then the next process is degree of improvement is also used to determine the effect of dynamic compaction. The number of drop per point and spacing is a factor affecting the compaction energy. Next is the most compacted point. The X per D ratio of the central location are around 1.5 and 1.75. For the data and result, in Article 1, there are 3 tests shown in dynamic compaction work better and can prevent soil failure. First one is the field density test, dry density test. The dry density of soil was around 1.6 to 1.7 gram per cm cube before dynamic compaction and increased to about 1.92 gram per cm cube. For the plate loading test, settlement value due to loading reduced with increasing of induced energy. For a standard penetration test, it can be assessing the density and liquefaction potential of a soil layer. One of the important approaches in treatment of failing material was getting to a larger and more stable SPT values that liquefaction hazard removed, which is shown in figure 1. We can know that after the compaction, the SPT value was increased and the line drawn are away from the liquefaction criterions. For Article 2, HDC shows a decrease in void ratio of soil. 2 test results were selected and are related to in situ soil condition. In these test zones, heave and penetration tests before the initial of job to optimize the number of blows per pin in different soil types and determine the optimal energy delivered. Once these 2 steps are determined, the heavy dynamic compaction is produced, followed by systematic pressure meter testing. HDC is appeared to be a very effective way in terms of performance of structure and cost improvement. So these are the 2 diagrams which show the value of limit pressure and the Mernat modulus was increased, which means the soil is more stable.
I'm Chang Kim Hui, and I'll continue presenting for the results. For the third article, it is found that a pounder with a smaller base area will penetrate deeper than a pounder with a larger base area. And it is found that with a deeper penetration will cause a higher densification. By using the formula V1 equals the integral of AT dt plus CV, where measured velocity is typically about 80% of theoretical velocity of falling of pounder. A result shows that excess pore pressure increases with increasing number of drops. Thus, it will directly reduce void ratio of the granular soil. In general, QC value is the lowest and the soil is the least compacted. Therefore, the centroid point may not be necessarily the ideal point for verifying the extent of improvement. Next part will be the conclusion. Okay, overall, we can conclude that dynamic compaction is one of the best soil improvement methods when dealing with large-scale projects. Dynamic compaction is cost-effective and competitive with alternative foundation systems such as backfilling and so on. From the result of the 3 articles above, we can summarize that the dynamic compaction is useful at earthquake-prone areas and loose granular soil structures in finding a desired bearing capacity and liquefaction. By dynamic compaction, we can also estimate the influence depth, suitable spacing, the required energy, and the number of passes by applying the well-established generalized empirical correlation to modify the dynamic compaction. And for the last part, this is the Fila table. That's all from us. Thank you.